Okay, hi, this is Mrs. Allen back again with absolute value and piecewise functions. And remember that we are working on evaluating limits analytically. So the topic that we're working with right now is rewriting absolute value to evaluate limits of functions. So what we're going to do on the next page is we're going to look at what would happen with an expression that looks like the following, where we want to find the limits for each of the following if they exist. If not, explain why not. So the first thing that you want to do is notice what we have. We have a left and a right hand limit, and then we have a limit. C is the limit as x approaches 7. So find the limits. So what we're going to do is we're going to rewrite this expression. I'm going to do a little aside on this. I'm not going to do all the work here. So what I'm going to do is I'm going to say I have 7 minus x over the absolute value of x minus 7. That's my function. Now, what is this equal to? Well, there's a breaking point on this where we know that if x is a certain value, things might change a little bit. So let's look at a number line and determine that. I hope you can see that the critical number here is going to be x is equal to 7. So I'm going to put 7 on the number line, and I'm going to look at a couple values to the left and the right of 7. Working with numbers always makes things really super clear. So before we get into the algebraic expression, I'm going to say 7 minus, I'm going to pick a value over here, 7 minus 6 over the absolute value of 6 minus 7. And to the right, I'm going to put 6 there. And then to the right, I'm going to pick another value, 8. So then I'm going to say 7 minus 8 over the absolute value of 8 minus 7. So clearly you can see on the left-hand side, you get 7 minus 6, which is 1, over the absolute value of negative 1, which is 1 over 1. So we know that that's 1 on the left-hand side. On the right-hand side, we get 7 minus 8 is negative 1 over the absolute value of just 1. So that's going to be equal to negative 1 over 1. So on the left-hand side, it appears that we have 1. On the right-hand side, the value is going to be negative 1. So now we might try that with a few other values, but with induction, after a couple tries with values to the left and right of 7, we're going to find that all the values are going to be 1 or negative 1. So what we're going to do is we're going to take this expression and we're going to simplify it according to the absolute value rules. So I'm going to take that on another page and I'm going to say 7 minus x over the absolute value of x minus 7. So this is equal to, then, think about this just ever so briefly, that it's equal to 7 minus x over the opposite of, hold on one second, 7 minus x, do I want to do that? No, I'm going to say 7 minus x over, well, that's why I start over, 7 minus x over x minus 7 if x is greater than 7. Okay, if x is greater than 7. The absolute value is the part that's going to be the same as x minus 7. Absolute value of x minus 7 is equal to x minus 7. So if x is greater than 7, no problem. Notice I'm leaving 7 out of the mix. The other one is 7 minus x over the opposite of x minus 7 if x turns out to be less than 7. So, and the reason being is that if you put in a number less than 7, such as 6 minus 7, you're taking the absolute value, you get the absolute value of a negative, but it becomes the opposite of negative 1 or positive 1. So we have our definition. So our definition of absolute value, according to this function, can be simplified.
Because we look at this and we just say, well, by golly, or maybe you don't say by golly, some people do. Some people still do. 7 minus x, the opposite, or 7 minus x over x minus 7 is the opposite of 7 minus x. And then in the bottom, what do we have? We have 7 minus x, and the opposite of x minus 7 is 7 minus x. So this is equal to, and they cancel, but you still have your negative sign here. And these cancel. So up top we have -1. On the bottom we have +1. So it seems if x is greater than 7, your function value will always be -1 with this guy. And if x is less than 7, then your function will always be 1. I lost my pen. Oh, I got my pen back. Let me try to erase that and fix it. Okay, so if x is less than 7. So we have our piecewise definition here. So I'm going to bring that over to the previous page. So it looks like, take this off of here. I'm going to write this up here. 7 minus x over the absolute value of x minus 7 is equal to 1 if x is, and remember we just did this on this page, 1 if x is less than 7, and -1 if x is greater than 7. And as I said, when you're working on these, you can always pull up your, put in your numbers, plug in your numbers. So, and then let's look at what we have now. So we have our x value coming in to 7 from the left, and here on this side we have x value coming to 7 from the right. So let me draw a bigger arrow here. So on the left-hand side of this, we have this is equal to the limit. Well, why don't we just put the answers? Let's not have any more frill about this. So on this side of 7, on the left-hand side of 7, we know our function is always equal to 1 over here. And on the right-hand side, it's always equal to -1. So here we're approaching from the left-hand side. Here we're approaching from the right-hand side. You're thinking about Alan, I'm doing my cursive, trying to get it all out there. So here, as you approach 7 from the left, this value is going to be 1. The function value will be 1. On the right-hand side, the function value is going to be -1. So we have this situation where from the left and the right, the function values are not the same. So what do we have here? This does not exist. The limit, the two-sided limit, does not exist because the limit as x approaches 7 from the left is not equal to the limit as x approaches 7 from the right. And that's all you wrote. That's it. So I'll let you go over that one. Take some time and go to your calculator, and I'll do it quickly, and you can evaluate what we're talking about here, and just put in the function 7 minus x parenthesis divided by math. Oops, did I get there? Math. Oh, gotta go back. Math. Go over to number and 1 for ABS, and put in x minus 7, and just try to
look at graphs at times because sometimes it becomes crystal clear with what you're dealing with. And there you have it. Now you can see at x is equal to 7, as you approach from the left and the right, you have constant linear functions. The value is 1 from the left everywhere, and it's -1 on the right-hand side everywhere about 7. So you can take a look at that. All right, so for the next one, we're going to find the limit, and we're going to move a little faster with this one. We're just going to say that we need to find the limit of this, so we're going to take the absolute value of x minus 4 over 2 times the quantity x minus 4. I'm just going to go ahead and factor it. So then 4 is the point of delineation here where you have a sign change in your absolute value expression, or your expression x minus 4. So let's write this out. It's then going to be equal to, if you go greater than 4, then think about this. I'm only going to talk about the absolute value of x minus 4. It's equal to x minus 4 over here. The absolute value of x minus 4 is equal to the opposite of x minus 4 to the left of 4. Kind of see that delineation there. So as we write out our absolute value, we would just say, okay, it's equal to x minus 4 over 2 times x minus 4 if x is greater than 4. We can't use 4. And it's equal to the opposite. Now I'm putting the opposite in with the absolute value because that's where it's equal to the opposite of x minus 4 over 2 times x minus 4 if x is less than 4. So let's rewrite this a little bit simpler. So then this becomes equal to 1/2 if x is greater than 4, and it's equal to -1/2 if x is less than 4. So if we're looking at the value of 4, we can say, okay, it's 1/2 and -1/2 for the function values. And again, you can put it in your graphing calculator. So when you're looking at a value like this, we can even graph this. It's not too hard. 1, 2, 3, 4. So we know that we have a function value of 1/2 and -1/2. And so we know greater than 4, the function value is over here. Less than 4, it would look like this. So again, you can kind of see that idea as the limit, as you approach from the left and the right, doesn't exist because it approaches 2 different values, if you will. So as I look at from the left and the right, then I would say the limit as x approaches 4 of the absolute value of x minus 4 over 2x minus 8 does not exist. And I just remind you that that is, we often spell out D-N-E. We don't spell it out. We just say does not exist because the limit as x approaches 4 from the left does not equal the limit as x approaches 4 from the right. Okay, so this limit does not exist. Okay, we'll pick up in the next video and finish up this section. See ya. This is Mrs. Allen signing off for now.